So in the last class, we started the section on network virtualization, and there we discussed about the necessity of the network virtualization, why we need it, and then we started talking a little bit about network function virtualization. Next, uh, we uh, we discussed about why we need a network function or network virtualization. So the main reason for having network virtualization is that with the massive amounts of hardware and physical equipment that are added to the network, the network that we are using gets bigger and more complex. So once we are sending some information from one point to another point, then the data might not be going through the optimal point, optimal route. So in order for us to organize the communication like properly and have a good overview about the communication that we do from the source node to the destination node, uh, the a new concept have been proposed, that is network virtualization. So by doing network virtualization, the network can be controlled easily, and the functions that the network performs can be done easily, and that is done basically using software programs. So virtualization means that we are using software programs to bring out network functions such as routing, firewalling, load management, and so on in the network. So rather than using specific hardware for that, we can now perform that using software programs. So once we can install such software programs in servers and in virtual machines, uh, we can uh, uh, we can easily manipulate those uh, uh, I mean those programs, and we can update them, and we can customize them as we want according to our need. So so in the past, we had very rigid and expensive infrastructure where we had to apply hardware infrastructure for each specific application, and we had to apply. We had to use specific hardware for the specific scenario, and this involved using specific infrastructure and the skilled people to go and like fix the network. However, once however, now we have come to the conclusion that this is not practical in all cases where we want to enlarge our network within like very easily, like within very few minutes or very few like days. uh, we want to enlarge our network. So if we want to do that, uh, this kind of approach might not be flexible. So in this approach, like in the traditional approach, we have like infrastructure specifically like fixed or like connected in the network to do specific functions and uh, forward the data in the network. So however, this kind of infrastructure is too expensive, and it is difficult to manage once the network gets bigger. So as a solution, people have come up with the network virtualization. So basically the challenges that we have with the non-virtualization or with the current systems are like not having enough flexibility, having high costs, and not having enough agility in our system. Agility means like how much we can adapt to the networks changes, right? If some link gets broken, and some route is not working well, then the communication that was previously determined cannot be done. However, and like if we don't have the current, I mean, software defined networking, we might have to fix the broken link, and then we have to maybe find another link after running a lot of other communications between these nodes, right? So I mean, for example, if I want to make a communication between A to B, I will first go through this route since it is the shortest, right? I will select. However, after some time, if one of the links get broken, if for example, this link gets broken, then again, I need to find a new route which will route my data from A to B. In that case, I need to find the optimal route by sending messages to each of my neighbors, right? So there could be other routers which are going to other destination. However, I need to send control messages to all other neighbors to find out what is the best path to go to the destination B. So rather than, so in that case, I'm sending a lot of control messages to re-update the communication link. So in that method, so I will be searching for the best path, and then maybe I will decide that this is the best path to move the data packet. However, there's a considerable delay in deciding that, and the amount of control messages that we are using to set up another connection is high. So in that case, the agility of the system can be considered a bit low. That means that the adaptability to like different changes in the network due to some situations in the network and some load, I mean, some changes in the load in the network and the link crashing that which happen. So because of those things, the ability of the network to adapt to the link failures and other like sudden changes in the network drops. So in the traditional network, it's taking some difficult, I mean, some time and considerable time, and it is much complex, and it adds more network traffic to the network to find the next best path to forward the data. However, now as a solution, the network virtualization has been proposed. So network virtualization means like virtualizing the network functions, right? So basically virtualization means making them more softwareized. I mean, like adding more software programs into these functions. That means that rather than using hardware for different functions, uh, now we can use software for network functions, right? Now we can use software for almost all functions. It has happened because all these years, I mean, through the history, I think the software industry has developed a lot. So now the softwares are able to actually do most of everything. So it has come to the stage where softwares are able to like code the functions of the network, right? So network functions such as uh, routing and firewalling, data forwarding, right, which were kind of done using specific hardware. Now we can actually use softwares to do that. So softwares means like we can code them in a script, and we can write a code, and we can ask that code to be run every time we want the function to happen. So once the code is run, the routing action will happen. So for this code, we have to provide some input data, right? So, and some kind of other parameters that should be included into the function in the code. Once we give the correct data, and once we give the correct information about the current situation, the code will give us the correct routing option for us right? What is the best node to forward our data next, and so on. So basically we are using software programs to do the network functions, right? So network functions uh, can be done using softwares. And apart from that, network controlling can also be done using softwares. So network controlling done using software we call as software defined networking, right? So network controlling which we do using softwares we call software defined networking, right? So software defined networking means we are using a controller in the network, right, where the controller is programmed using set of softwares and APIs, right? We have, once we have a like a collection of the correct softwares we need and APIs we need, we can correctly like deploy this SDN controller, and this SDN controller is able to identify the situation or have a global idea about all of the nodes to which it is connected, right? So the controller is connected to each of the routers or the switches that are there in the network that is considered, right? So let's consider that this is a local area network. So in a certain region we have a local area network where we have set of routers and switches that are connected to each other, uh, that that carries data traffic from one end to another end. So right, so any router which is connected from at any point in the network can go to another point in the network using this route uh, routes that are there in the network. So any point in the network can go and like request for like a communication with another person in the network. So once the source node want to communicate with the destination node, the the source node will first check whether a source node can by itself decide the best route, right? If it can like decide on its own, then it will do just like that. So it will decide the best route and forward the data packet along the best route that it thinks it is, right? If it decides that it cannot decide the correct route or the optimal route, then it sends a data or sends a like a message to the controller, which is here, right? A controller, uh, and ask for the controller to make the decisions for it, right? So instead of this person making decisions, now this person wants to ask from controller to give him directions to which direction he should send the data along and so on. What is the optimal path for me to use? So that question is asked by this source destination. So once the controller gets that message from that source node, controller decide like after seeing the entire topology of the network, right? The controller is able to find what is the best path for the data to flow, right? So the controller defines, okay, this is the best route for you to follow, and update the routers that are involved in the route. And then the data can easily be forwarded by these routers or switches based on the control commands given by the controller at each of these routers, right? So the routers are waiting for the control commands by the controller. After getting those commands, the routers will forward the data to the next node that the controller has advised them to send the data. So likewise, the data communication will happen from one node to the other node by the help of the control decisions made by the controller, right? And the controller is stored in another uh, like a server or a virtual machine. Okay, so the controller is is installed in a virtual machine or a server, like a hardware based server, right? So in that server or in that virtual machine, the controller is run using a software, right? So there also we have used a software program to get the function or create the function of a controller, right? So this controller we can actually manipulate as we want, right? So we can change the code in this, and we can customize the function of the SDN controller based on our requirements, right? So apart from that, the communication protocol that is used by this controller to communicate with the routers or switches is known as open flow protocol, right? So open flow protocol is a very like open protocol that uh, allows the programmers to customize the code which uh, which determine the uh, behavior of this protocol, and also behavior of the communication done by the controller. So the open flow protocol actually can be updated and modified by another person if they want to. So therefore, this is a very like customizable tool, and like the original version will remain the same, but the developers can change this protocol based on their requirements as needed, right? So therefore this open flow protocol is widely popular around the, I mean, in the world because of its openness and ability to modify, being providing us the facility to modify the codes and the internal, you know, functions of the open flow. So basically, I think I have covered most of the things regarding the software defined networking as well. However, we will go through each of those steps using an example scenario as well, right? So also, I mean, in order for me to like explain these two figures, like last week we talked about this section, right, where we talked about network function virtualization. So network function virtualization means that network functions are software programmed. That means that let's assume this is routing function. This routing function is coded inside a script. So inside the script, we can code the network function, and then we can install it as a software. I mean, we can generate it as a software program, and we can install it in a virtual machine, right? The one good thing about this is that the virtual machines also can be like updated as we need it, as we need. We can remove softwares from here if we need, right? We can remove any softwares if we need, or else we can put any softwares we need to this virtual machine, right? So depending on the network condition, depending on the requirements from this virtual machine at a certain instance, the functions that are used at this virtual machine will be, can be updated and modified. So that is also one of the functionalities of this network virtualization, and specifically network function virtualization. So this is a very flexible situation, therefore. And therefore, after like configuring each of these, you know, virtual machines that will be used as, uh, for example, for routing data, right? So these virtual machines can be used for routing data, right? So from one end to another end, right? So once we can actually consider communication from one end to another end, we can actually like program the routing function inside a virtual machine, and we can consider these virtual machines as routers. And then we can send our data along this path. And then uh, once we send data from one end to another, and up to from one another end to another end, we can actually program each of these routers according to our needs. Network functions can be adjusted. Apart from that, the data that is flown across this route the routing path, this path is decided by the software defined networking, right? So that is what is shown in here. So whatever the data that is passed from one virtual machine to another virtual machine, right? So the data will be passed based on the instructions given by the controller. Controller will decide this is the best path for you to send the data. So the controller is sort of like the above, like top view or top view person who has a global view of the network. So it has the global view of the network, and it has the total knowledge about the system and the network. So therefore, it has the ability to say from this node, the best way to go to the other node is that specific node, because it knows the entire network topology, right? What devices are connected to what devices. Likewise, it has the total idea about the system. So the controller will have connections with each of these routers or switches, right? So every time the controller will keep a topology of the devices in its network, and then based on that topology, it will basically use a certain algorithm and decide this is the best path to forward the data. Based on that, the controller will design whatever what are the best path that a certain route should follow, and the path will be communicated by the controller to the router. So once the router gets that information, the router will get information saying, okay, you need to send the data to B or something. So once it gets that information, then it will directly send the data to B. And then once B is there, once B is having the data, now the controller is sending data saying you should send the data to the node C. Then now if there's a route here, then we can directly send the data to route C. So based on the commands received by the controller, the nodes will send the data directly based on the commands. The nodes don't have to think anything about what is the next best node. It only has to forward it to the destination that is specified by the controller. Right? I hope it is clear to you. If it is not clear, please let me know. So let's go to the other slide. Mm. So the network, software defined network is different from the traditional network. So in conventional networks, the routers, switches are configured manually, individually, and the routers and switches manage their data, transmission individually. They individually think what is the next best path to or next best route to forward the information along, right? So each switch will make decisions at their own location, right? So earlier, therefore, like we call this distributed method of, I think, like mostly we call this distributed method, right? So at each router, they are making a distributed decision, like individually they are making a decision what is next best thing to do, like what is the next best node to forward the data in order to reach a certain source node, so destination node. So in here we had a distributed system in the traditional network. However, now we have a centralized system, centralized controlling system. Now, earlier we had a distributed controlling system. Now we have a centralized controlling system. The control only is centralized. The data forwarding is done in a distributed manner at each device level, right? So, each person is sending data on their own. Like the centralized controller is not forwarding any data. The routers have to forward the data. The routers are having the data. They are forwarding the data. Individually, they have to forward the data. So they have to do the forwarding of the data function individually. So a data plane is distributed in the, SDN and in both networks. So however, the control plane or the control function is centralized in comparison to the traditional networks in the software defined networking, right? So this is centralized in SDN. So this is controlling is distributed in the traditional networks, right? And then based on that, different performances are achieved at these two different types of networks. So we will look at the benefits and those advantages of SDN, right? Apart from that, SDN is the technology that uses a software based controller or APIs to communicate with underlying hardware infrastructure and direct traffic on a network. So I hope you can understand that. So it basically means that you are using either the software-based controllers or software-based APIs, right? So APIs, controllers, right? Software-based, programs are used to uh, build the controlling system, controlling plane, right? Control plane is built using softwares. So the softwares now are able to do the functions of giving commands to the routers and switches. And after giving commands, they can direct the traffic on the network, right? The routers can directly direct the traffic according to commands given. And so that is basically what is happening in SDN, right? So it is, I think it's a very flexible method that is followed in networking. So there are three main, once we actually see the overall view of the SDN architecture, right, we have three different layers, right? So we have application layer, right? So in application layer, it is basically the application that we are using. So different users could be using a different application. So let's take user one is using network application one, and the user one is sending commands or sending a request to initiate the communication and connect with another source, destination node, right? So in order to do that, first it will access the control plane using APIs known as northbound open APIs, right? Northbound open APIs, there are examples like REST API and Java based API, right? So you can search about this. As I remember, these are the basic APIs used for the northbound API. So using these APIs, the application will access the network controller, right? So once the network controller knows the application or the request of the client, right? Request made by the client, the network controller will observe the network topology and will update each of the routers or switches that are required to do this communication that is requested by this certain client. The software controller will decide, okay, these routes are needed, right? So these are the routers needed. So I will inform them what is the next optimal way to forward the data. So the controller will inform all these routers which are selected to forward the data about the optimal path that they should forward the data that will come under the client's request, right? So therefore, once the client starts sending the data, the data will be sent along that specific path defined by the controller. So so basically that controlling commands are given using open flow protocol, right? So basically that is the structure of the SDN. Apart from that, now the network applications, like the users, the applications of the users, right? The clients, right? The clients are basically in the application layer, and they are using a certain network application that requires network connectivity. And then also, then we have the control layer, where we have the controller, right? The most important component in the SDN. The SDN controller is there in the control layer. And then we have the infrastructure. Sorry, we have the infrastructure layer. So infrastructure layer means the layer which has the combination of the routers and switches that form the infrastructure of the network, right? So the network infrastructure is available in the infrastructure layer. So this provides us the communication between one point to another point. So it is the network infrastructure. So likewise, there are three basic layers of SDN network, and open flow is the protocol used for southbound interface, right? So open flow protocol is used, and it is used to do the communication required to do between the control layer and the infrastructure layer, right? Between the control layer and the infrastructure layer, whatever the communication that happens can be defined by the open flow protocol, right? So the open flow protocol also can be updated using by updating the software that defines this protocol. The open flow protocol is a open uh, open protocol which can be programmed by or modified by any person who want to use this protocol according to address his own unique needs, right? So that is basically about the SDN controller and the basic architecture of the SDN. Then we have the protocols used in SDNs, right? So we have basically two types of protocols, right? So the one protocol we call as the network traffic control protocol, and another one we call as network device configuration protocols, right? So the open flow protocol that I mentioned before is a network traffic control protocol. It's basically used to control the traffic in the network while we are using SDN architecture, right? It is giving commands to the routers, uh, mentioning what is the best route to forward the information, right? So if this is the best route, the best route will be commanded by this controller. The commands are given using the open flow protocol. Each of the router, the command messages or communication of data will happen using the open flow protocol. So the open flow protocol will control the data packet forwarding in a centralized manner using specific functions. It also allows own programs or scripts to modify the protocol. So anybody can modify the open flow protocol based on their own requirement, right? So this is something very flexible for any person, right? So depending on their company or their requirement, they can configure the network according to their needs by just updating the code in the controller. So this can be advantageous for a lot of people who does not want to buy new hardware to do the updates. They can just update the software. Next, network device configuration can be done using two different, these are main protocols. There are some other protocols also that can do these. So network device configuration means, like, first of all, once we are introducing routers, or once we have some routers in a network, before initiating data communication, we need to first configure each of these devices, and we need to give them the IP addresses and like any kind of uh, I mean we need to specify their configurations, and we need to connect that to the controller, right? We need to build the connection between the router and the controller, right? So we need to enable these routers to have connection with the controller, and after the controller is connected, the IP addresses can be allocated for each of the routers, right? And their own, their details can be stored in the controller, right? Their connection tables, right? How they can connect with another person, who are their neighbors. Likewise, data can be stored in the controller. So the controller will have a lot of information about each of the network devices after it first initialize the communication with each of these routers, right? So the each of these routers will provide their own unique IP addresses, maybe MAC addresses, right? So any of their unique information will be their unique data. Those things will be shared with the controller. So the controller will have the global overview of all the routers which are connected to their network. And the network device configuration will be done specifically using simple network management protocol and or network protocol, network configuration protocol, right? So you will ask like what is the difference between open flow and these protocols, right? You will ask that. So what is the difference, right? So open flow cannot do the network device configuration, and open flow is basically able to do the data forwarding process. It is not able to do the configuration of devices. It is not doing the device configuration process as of now. So therefore, currently we need to deploy other protocols like SNMP and netconf to do the network configuration step, where we set up each of the devices uh, based on their IP addresses and their other unique parameters. We configure those systems to connect to a certain controller and apply that like software defined networking concepts, right? So there's a controller here. So it can it should be first connected to all the routers. I mean, if there are any new routers in the network, that router should be first configured with the controller, uh, and then only we can connect that to the network, right? First, the any kind of new routers which are added to the system must connect with the controller to get information about the necessary data packet forwarding to be done. And the controller will also add a new like flow table regarding that routing table, and add its configuration in its server. So basically the controller will collect the information and configure this new router, uh, and make it connected to the software defined controller, right? Make it ready for the software defined networking architecture, right? So once it is established and connected with other routers and connected with the software controller, and after each of the softwares have been installed in these routers, the network is now this added router is ready to do the networking. So the configuration part will be, as I mentioned before, will be done using SNMP, netconf, likewise such kind of protocols. Right? So we need to use these different set of separate, protocols to do the network configuration, right? So however, these protocols do not allow the like own programs or scripts to modify the protocol. So the programs that are written here cannot be modified by the developers, so the people who are doing programming of these network functions. So there's some kind of a limitation or strictness in these kind of protocols. However, these protocols are defined basically for doing the network device configuration, which is a standard procedure that should be followed in a standard number of steps. So these number of steps may not be should not be altered by other people. So if it is done, then the configuration might not happen properly. So that is why these cannot be modified by outsiders or other people. So SDN for IoT. So once we take about IoT, since we are discussing about Internet of Things in this module, we need to see how IoT systems can connect with the SDN networking technology. Right. So in IoT systems, you know that we have sensors, applications, different kinds of data collection done at the edge of the IoT network, right? So at the edge of the IoT network, we are doing all the collection of the data, right? And there we have a gateway network, like gateway, which can communicate our data to a different network, right? So it can communicate from one network to another network, right? So this the component which connects the data communication or data packet forwarding from one network to another network, we call as the gateway, right? So the gateway can mostly be a router, right? Or another like server or something. So mostly we can use we can consider this also as a router, and then we can forward that data to our destination, right? So let's assume we want to save the data in a certain cloud server, right? So in a certain database. So in order for us to send the data, we will use a SDN architecture or SDN networking, right? In that case, each of the routers that they are uh, along, across the path that we want to send the data along will be controlled by the SDN controller. So therefore, the SDN controller will decide the optimal path for the data to be transferred across these routers, depending on the database that they are using for this IoT application. They will check, okay, what is the best method to access this database? What is the best path? Should we take this path or should we take this path? Likewise, they will decide, right? So the controller will decide based on the traffic in the network, what is the best path of communication of data from the from one end to another end, right? So the SDN control can be used for us in such a way for the IoT systems, right? So then we can actually also consider a simple scenario where we can understand the SDN process, right? So in there actually we have like a situation where we have uh, the SDN controller, right? SDN controller is at the bottom here, right? We have SDN controller, then we have a client who will request to connect with the database, right? He wants to access this database and maybe store his information, as I mentioned before, right? If we consider IoT application, the IoT client or this device will send the data from that end to the database. So in order for sending the data, they will use SDN architecture, right? So in that case, first the controller will first understand the topology of the network, right? So the controller will be responsible for the routing of the traffic, understanding the network topology, and if there's a fault in the system, to correct that fault. Then the data plane will be responsible for forwarding of the traffic to the destination routers. That's all. The data plane will only forward data. So the decisions made by the controller will be given to all the routers. Routers will behave according to the decisions. So the control plane is the most important part in the SDN. So the control plane will understand what is the best method to communicate using the network architecture, network topology available, and also they will also decide they will also consider the requirements of the user. If the user says, I want to send this data with some kind of a performance. If for example, if it wants to create lesser network traffic, right, reduce network traffic or network congestion, and then it wants faster delivery or something, right? So based on the quality of service requested by the customer, the controller will decide this is the, or a certain path is the best method to transfer the data, right? And then the controller will talk to first the switch which is connected directly to the uh, client will first make a decision whether the switch itself will do the, I mean, uh, do the communication to to the nearby routers, or it will ask from the controller to give him instructions on how to forward the data, right? So the switch will decide first whether it is going to use the help of SDN or not. If it decides it's going to use the help of SDN, then SDN will send him data about what is the best method to forward the data, right? So if the switch is deciding to use the controller's help, then the controller will decide, okay, this is the best method to send the data, right? So the controller will indicate this is the best path. This green path is the best path to forward the data. Right? The controller will give the instruction to each of the routers who are in the partaking in the one of the like in this route, and the controller will ask them to forward the data. So the whatever the control protocol that is used in this communication is the open for protocol, right? So if you have any questions, please ask. Apart from that, so right, so once the sorry once the switch makes the decision to take the control decisions by the centralized controller, then the switch a message will be sent to the sent to the controller by the switch using a secure channel. So after that, the controller will decide how to do the flow of the data, and based on that, it will give instructions to each of the routers. The controller will also maintain flow tables or connection tables in its own server. It will have like connection tables about each of the routers in the network in its server. It knows the entire like communication, how the communication will happen at each router, and what are the connections that each router has with the other routers. So then we have right. So uh, then we have a situation where the links are not active at some points, right? If one of the links get broken or something, then the SDN controller will decide, okay, there's some link like failure. Then in that case, that switch will the switch will not no longer be active, will be removed from the table, right? Removed from the so that controller, right? The controller will not keep the table in its server, right? It will remove the details about that switch, because that switch can no longer be used in for communication. Then right, so there's a benefit of doing the centralizing of the connection request, right? So right, so once we are doing some communication, once we are using the SDN controlling method, when there's some kind of problems that happens, then the controller can easily understand it, right? So the reason is, like, in cases where some communication requests are coming from unauthorized people or unauthorized devices, then such kind of requests, or I mean, if some routers uh, make some, if some uh, problems occur in the network with related to communication requests that come from unauthorized routers, right? Which are not connected to this network, right? If there's any component which is making request directly to the central controller, then that central controller will definitely know, okay, this is an unauthorized person, because the centralized controller knows which devices are connected to its network. If there's any outsider which is not configured to the network, then it will definitely identify this very quickly. So any communication requests made by this kind of a router, right, will not be taken into consideration by the controller. So therefore, in this kind of situation, uh, right, in this kind of situations, the connection request by these kind of routers will be not be addressed by the controller and will be rejected by this controller. In that case, we can reduce the amount of like unnecessary traffic that is caused by these kind of unauthorized devices, right? So the unnecessary traffic that is caused by these unauthorized routers are called as denial of service attacks. That means that they create some traffic to the nearby routers and switches, and the routers and switches assume that there are some uh, communication problems in the network, and then they they also might get impacted because of such kind of like unnecessary traffic that is added to the network. Therefore, communication cannot happen smoothly as before. If so In that case, if we allow this kind of a router to stay in the network and communicate freely, then our congestion will increase and our communication cannot be done properly. So however, now once we have SDN architecture, once we don't allow this person to communicate with others, that means since the centralized controller allows the routers to communicate with each other and make the routing of the between the routers. So the controller will not allow this unauthorized router to connect with any of the other routers. It will not create a route between this unauthorized person and authorized person. So therefore, it will deflect such kind of unauthorized access into the network, right? So with that, actually, I will stop today's class. So I hope you were able to understand. So if you have any questions, you can let me know, and we will discuss that in the interactive class or in the next online class, right? So let me know, and thank you for attending today's class, right? So I will end the recording.